All right, so we kind of went through this quickly, but I still like to think it through a little more. So I would tell the kids that we are reviewing division, and that's so we can move into division with fractions. And I would ask the kids, all right, I want y'all to think back. Division. When we divide, there are key words in the problems for division. So, and I want y'all to think about this. When you divide your candy, when you divide a pack of cards to play a game, what are some words? I mean, what are you doing? Okay, sharing, that's true. Sharing, I may add that. But fair share, right? And maybe that's where I would start. What is division? Division is splitting up, right? When we split up the class, we're dividing it. Division is sharing, because when you share candy, you are splitting it, you are dividing it between people. Separating. When I separate two kids who are acting a fool, that would be because I need to divide them or split them up. So division is splitting items up. It's sharing them. It's separating. It's splitting a whole amount into parts. And we call this fair share. Now, how do we know that it's fair? Well, because you have keywords like equal, same, even, and even each. Now, each is not just division. Each can represent multiplication, or it can represent division. And that's because each can be grouped all together, or each can be grouped apart. And division is grouping. It's fair share grouping. Because when you split it up, it's the same amount per group. When you separate with division, it's equal groups. So we call it fair share because it is fair if you and I have an equal, or you could even say an even amount, or the same number of items. It's pretty easy to remember too, because if I had a bag of candy and I just start grabbing handfuls and handing it to each one of you, Landon may get 10 pieces, Owen may get 5, Catherine might get 1. And what's going to happen? What am I going to hear as I pass out candy and everyone gets different numbers? That's not fair. So when you think of division, when you think of your teacher splitting up candy or separating it, those are big keys that you're dividing. And when you divide, you want it to be fair. When the sharing is happening, fair share. Equal is fair. Getting the same amount is fair. If you and I have an even amount of cards, this is all fair. All right, so I would take, like I did, a little bit of time for that. All right, we're going to go back and look at these because these are division problems that we've seen or that are similar to ones we've seen. All right, so boys, read us what it says above the trumpets. All right, and then read beneath the first question. Read beneath. All right, so girls, what are we wanting to do? And we don't want you to read the whole sentence because if I said to summarize the book, you wouldn't write the whole book. So we're wanting to what? Arrange. Arrange what? Trumpets. How? 3 equal rows. And we want trumpets each row. Well, what do we know right here? Equal. Equal is fair. And why is it fair? Well, if you and I have an equal amount, it's fair. And when do we care if we're fair? When we're sharing, which is a huge, huge hint for division. So we want to know the trumpets in each row. Each row, it's because you can either group each all together or you can separate them. In this case, we have the whole amount. We know there are 18 whole trumpets. So if we know the whole amount, the part in each row, the whole amount is not in each row. Part of them are each row. And division splits you into parts. We're not building up, we're taking it apart. Now, 3 rows. Kids are going to try and make 3 rows. That's not what we do. We use the keyword 3. So you can go throw that away, Owen. Ask your brother if he wants some. 3. And it doesn't really matter, but we're going to make groups of 3. So I want everyone to make groups of 3. And then I want y'all to answer how many groups you made. And then we'll compare. And I always freeze my frame on my TV at this point so they can't see me doing it. But I go ahead and work it out. And all the kids can see is a frozen screen. You might have to minimize. I don't know how yours works. So I would have mine done. And then I would walk around real quick just to see, are the kids splitting in groups of 3? Do they have the right answer? Kind of let you gauge who's got it and who doesn't. And then I would ask them, what do y'all think the answer is? Hopefully most of them say 6. I don't call one-on-one. I call as a whole group. Gives them a little confidence, and it encourages all of them to practice. And I would say that's what I got too, because here's 1 group, 2, 3, 4, 5, 6 groups. Why do I know this is the answer? Because 6 groups of 3 is 18. All right. Girls, read us about math class. So the girls would be reading this. Landon, hold this for me, please, for just a second. Sorry, Owen's decided that he needs a pickle. Oh, Owen, I don't know if you'll like those pickles.
Can I put on a chicken?
Yeah, I guess. All right, so what are we looking for, boys? Let's summarize. We're looking here in the question. What are we looking for, boys? Flashcards. Where? Each student. We want the number of cards each student took. Baby, I don't know that you like these. Daddy got sweet pickles. These aren't dill pickles. They're sweet. You better try one first. All right, so I would ask the kids, do we know, are we missing a whole or a part? Did each student take the whole stack or part? Part, that's right. Yeah, they're nasty. Go get the other pickles. Are parts big or small? Small. So how do we get small in math? Well, we either subtract, which means we take away, or we divide. Do we have any hints? Are we taking away, or are we splitting things up? Are we separating? Are we sharing? Oh, yeah, look right there. I saw it. Now I've lost it. Splitting. If you are splitting them up, if you split up a shape, hi-ya, you divide it. That's separating. All right, well, what do y'all think I should separate it in? Or how many cards do y'all think there are? Yeah, I do too. I think there's 65. That is your whole amount. So we know there are 65 and we're wanting to split them. So what should we start grouping them in? Oh, look, there's a fair share where it's same. If you and I get the same amount, it's fair. And when is it fair? Or when do we care if we're fair? We care when we share, when we divide. Groups of 5. So 1, 2, 3, 4, 5. Let's circle. Let's do this one together. 1, 2, 3, 4, 5. All right, y'all. Let's start on the next row. 1, 2, 3, 4, 5. Y'all count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I remember this one because everything is working as 5s, and then all of a sudden it won't. Right here. All right, let's go count how many groups of 5 we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 groups of 5. So, what's the number of flashcards each student got? Well, there are 5 kids, so they each got 13 cards. All right, class, I want y'all to read about Kevin all together. All right, class, read the question. And if the kids get off or aren't reading well together, make them restart. That's building fluency. All right, so let's summarize. What are we looking for? The number of what? Grapes. For who? Each boy. All right. Do you think each boy took all of the grapes or some of the grapes? Yeah, I think they took some too. So if you're taking some, are you taking the whole amount or a part? I agree, a part. Are parts big or small compared to a whole amount? Small, yeah. Part of the pizza is smaller than the whole pizza. How do we get small? Yeah, we can subtract or we can use the operation of division. All right, well, if we're missing a part, where's the whole amount? Oh, yeah, there are 27 grapes in the bowl. So this is our whole. 27 in all. Each boy is going to get part. Are there any hints to do subtract or divide? Yep, same. If you and I have the same amount of grapes, it's fair. And the only time we care if it's fair is if we share, which is division. All right, so it says right here to draw a strip diagram. Do y'all remember what a strip diagram looks like? Hopefully they say strips of paper, or then maybe they'll say draw a rectangle. If not, you'll have to remind them. Say, well, they usually look like a rectangle, and you've always got two strips. One strip represents the whole amount, and the other strip represents parts, whether there's 2 parts or 3 parts or however many. Hold on, because I can't write and hold. I'm too picky. Hold on. All right. So one strip is the whole and one is parts. Again, if the kids forgot that, or you might even show, I mean, this is how I always did. I would take a piece of paper and I'd tear a strip and say strip diagrams, because that's a strip of paper. Strip diagrams are like strips. All right, well, you and I said we knew the whole amount. What was the whole amount? 27. So up here we have 27 whole grapes. If we're missing a part, y'all said we got smaller, right? So what answers can I eliminate? Yeah, why can we get rid of A and B? Well, because they're more than 27. They do not make sense. If you only have 27 grapes, each kid can't be eating, 54 each. That's not reasonable. All right, same. If we are the same amount, what should we recognize about the parts that we're going to draw? They should also be the same sizes. The question is, how many parts are we talking about? Maybe they'll say 3. More than likely, a lot will say 2 because they see the number. But, and that conjunction, Kevin and his 2 brothers. Oh, and that's twice. Kevin and his 2 brothers equal 3. And we know that each one received the same. So we're going to make sure that the parts are the same size, same shape, congruent. And in the middle is G. What do you think the G stand for? Grapes. Very good, yeah. Kevin and his 2 brothers get grapes. Here's Kevin, and here's his 2 brothers. So we need to divide. How could we do this? Well, you could just draw 27 marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. What should I circle? Yeah, groups of 3, because we are splitting 27 into 3. 1. All right, so we're going to circle groups of 3 and count out loud. It doesn't matter where you circle. We're just going to count together, and when you're counting, you should be circling a group of 3. 1. Are you ready? 2, 3, 4, 5, 6, 7, 8, 9. 9 groups of 3. Well, and here's another way I could have done it. I have 27 divided by 3 equals, we said, 9. What is the opposite of divide? When you do a fact family, if they don't know, you say, well, fact family, 27 divided by 3 is 9. 27 divided by 9 is 3. What goes with divide? Multiply. Well, we could have looked at a multiplication chart. We could have gone and looked at our row, our 3 row, which would have looked like this. Our 3 row. We would have looked for the digit 27. So here's our row of 3. There's 27, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's no wrong way to do this. Whatever, you might ask the kids how they'd solve it, and then maybe show a couple of examples. Maybe one kid actually just drew the multiples out. Math, there's no wrong way. By the way, I skipped this. An equation, E, Q, U, A. He's trying to say, hey, I'm just a sentence with a punctuation mark. I'm an equal sign. And we all said this was divide, so it would have been 18 divided by, I don't even remember, 3. 18 divided by 3 was 6. I forgot that part. All right, the second page. This is the new stuff, so tell them, all right, that was all review. That should have not been new. But this is the new stuff. And notice that these say I do and these say we do. I'm going to kind of guide y'all through the first 2. And then I'm going to let y'all try the bottom 2. So do not get ahead, because you're not going to be able to do your own assignment if you're not paying attention. So now what we're doing is we're going into our fractional division. So, boys, read above and below the Skittles. All right, here's our question. So what do we want to know? Can 3 friends share Skittles equally? How many friends? 3. Catherine, Landon, Owen. 3 friends. Sharing. What do we know sharing? Yes, fair share, which is division. You only care if I'm fair when I share. Yep, there's that same. Same means it is fair, right? So, how many Skittles are there? There's 5, right? 3 friends. So, can each of us have 1 each? Yes, all right, give each one 1. 1, you get 1, you get 1. Right? Those 3 over there. Can we each get another set? Why not? Well, because there's only 2. Well, yeah, but you could cut them in half. Okay, we could in real life, but this is math, and it's math that they like to make up, and, where you're going to get diabetes from eating 800 Skittles, or, there's like 500 pieces of bacon. So, yeah, this is not real world, so we have to assume that their whole parts cannot be cut. The whole Skittle. So can we each share another whole Skittle? No. So, how many would each one of us get? 1. So, could we split these Skittles equally so that we receive the same amount? So this is kind of a yes and no. Yes, we could, but we're only going to get 1 each. Or you could say no, because there's 2 extras. Kind of depends. What could we do to ensure that all the friends receive the same amount? Ensure. So right now, we can each get 1, right? But there's 2 extras. So technically, could we split all of these Skittles equally? No, we couldn't. Yes and no. Remember, I don't really like the question now that I read it, but yes, we could each have 1, and that would be fair. But can we use all 5 and be fair? No, you can't use all 5 and be fair. So again, I would talk about both of those things. What could we do to make it more fair? Oh yeah, we could. We could add another Skittle. We'd capitalize Skittle, right? Because it's the name of a candy. What kind of noun is that when you capitalize it? That's 3. A proper noun. So see, you're bringing in language when we're writing. Okay, so you're right. If I add another Skittle, 1, 2, 3, right? 1, 2, 3. What else could we do? we could just take them away, right? What if we only had 3 Skittles? So we could take out extra 2. TWO, make them write it. 2, TWO is the number. So we could block out these 2 and then we'd each get 1. And so I'd get up and walk around at this point before going to the next one, make sure that they've capitalized, make sure that they're taking your notes, make sure they've got the right homophone, and tell them, okay, so this is kind of, we didn't write a fraction yet, but this is getting us to the fractional part. All right, here we go. Girls, read us about the popsicles or ice cream bars. All right, so what is our question? We want to know, can 2 teachers share bars and receive same amount? So how many teachers are there? 2. And any keyword? Yeah, sharing in the same. It's fair if you and I get the same amount. And the only time you care is if we share, which is dividing. We're going to split these up between 2 teachers. So can we do this? Well, 1, 2, 3, 4, 5, 6. Is 6 an even or an odd number? It's even. How do I know that? Well, I know it a few ways. I know it because even numbers end in 0, 2, 4, 6, 8. How should a 3rd grader know it? Also, we should also know that 2 teachers. I can see right here. 1 teachers. Another teacher. Right? If you can divide fairly, that's a big key that it is an even number. Could have come back, should have pulled back that it was a no because 5 is an odd number. Odd numbers end in 1, 3, 5, 7, and 9. And when it's odd, you cannot share equally, which then goes to say, see, that makes me think I would definitely say, no, we cannot use all 5 and be equal because 5 is an odd amount. All right, so back here.